Assalamu alaikum. So let's say I have a difference equation and also I have an initial condition. Okay, I have initial condition. Let's say it's maybe 3 or it may be 4, anything. And I want to find the value of y using this MATLAB code. But there is a problem. You might be thinking that you will use filter. Okay, you will use filter and find the value of y. A filter is the built-in MATLAB function, but no, you can't use filter for this case, because if you use filter, it will assume that your initial condition is 0. But as our initial condition is 3 or 4 or anything, so now you have to write a manual code. So in this video we will see, I will write a manual code here and then find the response of the system, and then we will make our initial condition, 0, and then we will find the response y. And as the filter function assume initial condition 0 and we also set initial condition 0, we will see that this y and this y matches or not. If they matches, that means we can verify that our manual code is perfect, our manual code has no error. Okay, so let's start. Okay, so let's say this is my difference equation and it representing a system. That means this is the system that represents this difference equation. So if I input any signal, then similarly then I will get any output, right? Okay, so now let's say that you have an input. Let's say that you have an input xn. It can be anything, and in my code I have set the time index starts from 1 and ends at 20. Okay, in my, you can change it, but in my code I have set it from 1 to 20. So the output might be from 1 to 20. So you are assuming that as here is no input, so there might be no output, but that's not true actually, because now you have initial condition. Let's say you have initial condition which is equal to 3. That means initial condition means before 1 you have 0. So at n is equal to 0 you have some value. You have some value, and this is the y initial. Actually this is the y initial. The value at 0 at n is equal to 0 is the y initial. So now let's see what can we do in our code. So let's see the methodology of our code. So first of all, we have to set our initial condition. Which is equal to 3, and then let's rearrange this equation. If I rearrange this equation, let me give a comment line here, then I will get yn is equal to xn minus 0.6 y n minus 1. So this is our rearranged difference equation. So if I want to find the first value of the input, that means output, that means at 1, then I will, here you have x1 and 0.6 y0. So see, this y0 is the initial condition. So this y0 is the actually y initial. Then you have to write a for loop where I will be from 2. Why from 2? Why not from 1? Because you have obtained the value of 1. So you are now starting this I from 2. Okay, so from 2 to length of n. Here n is from 1 to 20. Okay, and now you have to simply write this equation here. So instead of n we will write I xi then 0.6 y I minus 1, and finally you will get y. Okay, so let's see what happens. And yeah, for this y you have to make an empty array, like empty matrix. So you have to also make an empty matrix here. Okay, that you will understand in the code. So let's go here. Okay, so this section I have two inputs. One is step u, so I have made a step function here, and this is my sinusoid function. This is actually sin n. Into u n. Okay, so I have generated this signal. I have generated this sinusoidal signal, and also I have the step signal, which is actually un. So I have two inputs here. Okay, so first of all I take only sinusoidal signals and input. So x is equal to sine signal, then I will use u or anything, but now our input is sinusoid signal. And if I plot the sine signal, let's see. Okay, let me plot the sine signal. Then this is my sine signal. Okay, starts from 1 and it's at 20. Oh, one thing, our n is from 1 to 20. Okay, now first of all I have choose a empty array here, and our initial condition, let's say it's 3. Let's say our initial condition is 3, and then we have obtained the first value of y. Let me compare. Okay, so you see. Okay, so you see that first of all I have made this empty array, I mean this, and then I have an y initial, which is 3, like this, and then I have find the first value of output. That means I implement this line here, and then I have written a for loop here. This is useless line. Let me delete this, and then I have just write this thing, and then I have to plot. Then I have plot y, the output, and let's see what happens. Okay, so this is my y, and this y looks like this. And if I set initial condition is 0, and if I run this code, you will see that this is my input and my output looks like this. Okay, now the third about what I have told you, that now I will use filter. Okay, in this case, in this section, 1 minute please. Okay, so now I have to use filter. So how to use filter? Let's say you have yn plus 0.6 yn minus 1, then xn. So now I will use filter. Okay, and first of all I have to write here b, then a, then x. So what is b? B is the coefficient of x, which is simply here 1. And what is a? A is the coefficient of left hand side. So at the left hand side the coefficient of y is simply 1, and the coefficient of yn minus 1 is 0.6. So if I write this built-in function, I will get y, and in my code I have named it as y using filter. So my variable name is y using filter. So y using filter, I will get this. And remember that I have told you that our initial condition is 0, and we also said in our code that our initial condition is 0. So the manual code's output and this code's output may be same. Let's see what happens. Okay, so this is the manual code's output y, and this is using filter, y using filter. Okay, let's take some point. at x is equal to 14 you have minus 0.31. At x is equal to 14 you have minus 0.31. now let's take here at x is equal to 5 and at x is equal to 5 you have the same value. Okay, now let's change this initial condition to, let's say, 5 and see our two matches or not. I think it both, you see this two doesn't match. This is the manual code for initial condition and this is using filter, so this is wrong. This is wrong because initial condition is 5 but filter is assuming that the initial condition is 0, so don't focus here. The right answer is this, the manual code is right. Okay, so by this you can find any response using if you have initial condition you can find anything. Okay, let's do another thing. So our input was sine signal, so let's make it u and let's see what happens. First of all, let's make it 0. Initial condition is 0 and now let's see what happens. So these two might be same. You see, at first you have some transient part and after the transient part dies out you have the steady state part, and the steady state part's value is 0.6 and here you have also 0.6. as initial condition is 0, filter assume initial condition 0 and actually initial condition is 0. And then let's take some others value. There's initial condition is 10. Okay, initial condition is 10 and then if I run this code, okay, see these two signals is the same. You have a many transient part here. Now filter is not correct. Let me don't use this filter, just focus here. So this is only y, manual code's output. So this is the correct, filter's output is not correct. Now your initial condition is 5 or 10 or anything. So this is, you see that you have a great transient part here as you have initial condition and then it goes to steady state. Okay, so thank you.